Okay, everybody's got an attempt at an answer for each one? You have it?
Okay. I made a
Okay.
mistake.
Hold on to it for us. I mean, if you say, I don't know what the answer is off the top of my head, so even if you say it, I don't know if you're right or not. But hopefully, I'll give you a hint on number one. You should have two answers. Did you get two answers? Good thing we're reviewing. All right, let's give this a shot. Can someone refresh our memory what the very first step to any absolute value is, whether it's an equation or an inequality? The first thing you have to do, no matter what, is yes. Step one, get the absolute value by itself. So if I do that for number one, I'm going to minus 3. So I get negative absolute value of x plus 4 equals a negative 8. And then what? It still isn't by itself, is it? You got that negative sign out there. So how do I take care of that? Divide. I got to divide both sides by a negative 1. Now you stop for a minute and take a look. Because if this had still equaled a negative number, you would already know that there's no solution. Because there is no absolute value that could equal a negative. But once I have the absolute value alone and I look, I'm like, oh, it's actually an absolute value that's equal to a positive 8. There are answers to that. Let's find them. So to find the first one, I write x plus 4 equals 8, exactly like I see it. I don't change anything. I just don't write the absolute value first. Then the second time, I write it again, x plus 4, but now I have to take the opposite of this side. So I set that equal to negative 8. And now I just solve each one separately. So on one side, I'm going to get 4. And then on the other side, I don't get negative 4. I get negative 12. Those are my two answers. So when I go to list those answers, remember we use those funny curly brackets because order doesn't matter. I'm just listing them off. That's what the curly brackets mean. It just means, hey, here's all of my answers. Order is not a thing here. It's just a list. Can you check this? Of course you can. You can plug in 4 and negative 12 back in the original and your equation should hold. Okay, it's basically the same idea for number 2, the second one. But I'm telling you right now, a whole bunch of you are going to forget the crucial step. You ready? First, get it by itself. Divide both sides by 4. You can't distribute through an absolute value. That's not a thing. So now I'm here. And this is where some of you are going to mess up right here. So please watch because I don't want this to be you tomorrow. You have to rewrite it twice. The first time you write it just like you see it, no bars. The second time, please listen to me. When you rewrite it, you have to flip that symbol over and make that negative. You have to do both things. I know you forget about it because with an equal sign, you can still think that I'm flipping the symbol over and taking the, but an equal sign flipped over is still an equal sign. You got to flip that symbol. They flip. Now I solve each one. So I'm going to add the 3. So on this side, I get 6. On this side, I get 0. And now it's up to me to decide if this is an and or an or. So I'm looking and I got to say, okay, are there numbers that are greater than 6 and less than 0 at the same time? No. What does that mean? That means this is an or answer. So you have to put the word or. If I'm going to ask you to graph, which I think I do, the ors are just going to go opposite directions. So that one goes that way, this one goes this way. You can still check this answer. You can check numbers that you shaded over. Plug in -1, it should work. Plug in 7, it should work. If you plug in 5, it should not work. Does this make sense? Do you remember this? Is that okay? Everybody's all right so far? All right, the next section is the graphing absolute value stuff. So some of them is just a normal absolute value. Some of them are the inequalities. So it's been a while since we've looked at that. I know you don't have a graph in front of you, but I'll make this one nice and easy. So just give yourself a coordinate plane there. Go ahead and try and graph this. How about y is less than, let's do negative absolute value x plus 1 minus 1. Try that. So I know we don't actually have a graph, but if you just sketch a couple of spots, you'll be able to get it pretty well. So take a moment. Now you have kind of two different ways to graph this one. You could do the translations like we've just been talking about, or if you remember when we first looked at this, we just looked at the equation, figured out what the vertex was, and then followed the slope. Either way, it should get you the same graph. If you forget everything, just start plugging in numbers. Plug in 0, plug in 1, plug in 2, plug in 3. Eventually, it's going to give you the V-shaped graph that we know we're after. Okay, you got it? I would graph this. Is everybody with me? I would look at this and I would figure out what the vertex is. Remember how we did that? First of all, make sure that the coefficient here is 1, which it is. If it's not, remember you got to factor it out. So I'm looking at this and it's always the opposite of that number, comma that number. So I'm going to do a vertex at -1, comma -1. So I'm going to start right here. Then I just look to A for my slope. It's just a -1, so the slope of that right-hand branch is just -1. So I'm just going to go down 1 to the right 1, down 1 to the right 1, and then I just mirror it over on the back. The only difference, if it were an equal sign, I would connect the dots and I'd be done, right? But this is an inequality, so I need to worry about two things. I need to worry about if it's solid or dotted and which way I need to shade. So which is it? Which way is it, solid or dotted when I connect the dots? Luke? Yes. How do I know? Because it doesn't have that bar underneath, right? So I'm going to connect these with a dotted line. So make sure that yours is dotted. And then I also need to shade this graph. Where am I shading it? Sebastian? Yes, y is less than. So I'm shading below this line. All of this gets shaded. There it is. Let's try. Yeah, okay, we can do this one. What if I had given you one of those problems where, because after the absolute value stuff, then we move on to piecewise. So could you, yeah, let's try this. If I gave you a graph like this one, this is just number 6 from the homework last night, but let's pretend that my instructions were different. If I said, rewrite this as a piecewise function, can you do it? Let's try it. Rewrite as a piecewise. So there's our new direction. So check out this graph when we get it lined up so it doesn't move. I'll put some dots too so you can see a little bit better where all the dots are. There's a good one there, there's a good one there, good one there. So if that is helpful, you can follow the dots. Did you get an answer? I'm very nervous. I have like, I don't know, 1/3 of you with me and the other 2/3 are, I have no idea where. Yeah, this is the one I'm looking for. So remember we started, I'll give you a hint. We started by figuring out, okay, where does my graph change? Where am I changing from one line to another? This one has 2 branches. So we kind of like, we're like, okay, I'll have to figure out what those equations are, but let's figure out where it's splitting. Doesn't the whole graph change at 0? So this top one only exists when x is less than 0. And this one, this side only exists when it's greater than or equal to. Remember that you need to have that or equal to bar under one of these two, but not under both. It doesn't matter which one. So if you put it on the top, fine. Then you can't have it on the bottom. So there's your first step. You figure out where the graph splits. This one just so happened to be at 0. It could have been anywhere, right? It could have split at 1. It could have split at -6. It doesn't matter. Wherever it's splitting, you figure that part out. And then I just need the equation of each of these lines. So, and we always work from left to right. So what's the equation of this line right here? Y equals what? Sebastian, go ahead. -3. Where's it hitting your y-axis? Where does it hit the y-axis? So I need a +1 on the end. Right? Isn't that the equation of that line on that side? -3x + 1? Yes, okay. Then I do the same thing for this one. What's the equation of this line? Izzy, go ahead. Yes, +3x + 1. And there you have it. So there is rewriting an absolute value as a piecewise. Should we practice one more piecewise? I figured. Okay, so I'm just going to pick a random one from a worksheet that we have done before. Yes, I've got this one here. So let's do. I'm gonna give me a second. Let me erase these answers. Oh dear, I tried to erase it. It made it way worse. All right, so I have this random one here that I'm going to do. I'm sorry that you don't have it right in front of you. You do have it though. It is from worksheet 2-3B. So I'm going to do this particular one, number 10. We can do it together here and see if we all sort of match up. So pretend that this was all blank. First, I'm looking here and I'm saying, oh, this graph splits at -3 and at +3. So the first thing I'm going to do is I'm going to come in and I'm going to put vertical lines at -3 and +3. -3, put a nice old line there. +3, come over here. There we go. Okay, so please listen. This graph, we always go left to right and top to bottom. So this one only exists when x is less than or equal to -3. So I'm going to graph negative x plus 1 over here. In the middle is negative x plus 3, and then on the right is -3. Some of you are getting them all wrong because you are making one crucial mistake. Yeah.
Are we getting a repeat packet like the last test?
I can give you one if you want. Sure. Okay, look at 10. What was I saying? I don't remember. Oh yeah, people keep making this mistake. They go to graph negative x plus 1, and this is what they're doing. They're pretending that this is the y-axis. And they go up 1, and then they go down 1. You can't, the y-axis is the y-axis. I'm always starting here. So if I'm going to graph this one, I'm still starting at +1. I'm still following the slope down 1 over 1. The only difference is that I'm not going to connect these dots here. The line, though, keeps going. Doesn't the line just keep going all around, right? The line just keeps going, keeps going, keeps going. But according to this, you only draw this line right here. That's the only piece of the line that gets drawn. And when it hits -3, it's a closed dot because I have that or equal to. All these other dots should not be there. I needed them to figure out where my line goes, but now they're gone. It doesn't exist there. Stop pretending like someone else is the y-axis when it's not. You always start on the y-axis and then go from there, okay? To do the middle, I start at +3. I'm going to follow the slope this time, down 1 over 1. When I run into +3, it's going to be a closed dot. But look back here. When I run into -3 back here, it's got to be an open dot. And then I just connect those two. And then this one's nice and easy. -3. So that's just a horizontal line right here. It's got to be open though. That, my friends, is how you graph a piecewise function. Does that make sense? I think some of you are getting mixed up because you can kind of jump ahead. If you don't want to like trace it out, you can jump here, but you would have to plug in -3 and see where you start and then follow the slope backwards. Which sometimes you have to do if you run out of space. But anyway, so there's that. So there are a couple of piecewise, and then oh, you know what? Let's do it on here. Just there's a section where I ask you, hey, find f of 1. Find f of -6. So do you remember how to do that? Yeah, you have the graph and you have this. So it's up to you. If I want to find f of 1, I plug in 1 and I see what comes out. Oh, it's a 2. Or if I wanted to, I can actually verify that my graph is right by doing this. If I go up to the top and I'm just given the equation, if you have to plug in 1 to the equation, remember how you look over here and you figure out which one of these 3 1 actually fits into? You're not going to give me 3 answers. You're going to see, you're going to plug in 1. Oh, 1 doesn't fit there, so I don't put it there. Oh, 1 fits in between -3 and +3. So what does that mean? That means you come over here and that's where you plug in -1. So -1 plus 3 is 2, just like my graph said it was going to be. Oh, further confirming that I did my graph right. I do the same thing. If I want to find f of -6, if I have the graph, I can go to -6 and I can look at where I end up. I think that's +7. But let's confirm. I'll go up to my graph, -6. Oh, -6 fits in the top. So -6 is +6 plus 1, 7. Just like we thought. The only other thing that is on this test is just like we were doing with the homework. So I'll give you a graph and I'll say, hey, what's the equation of this graph? Or I will give you, there are 2 questions where I just write it in Word. So let me give you 2 of those to practice real quick. And then that's it. That's the whole test. So give me a second to write this. Oh. There we go. All right, everybody try this one. Get this lined up. There we go. So I might say to you in words, hey, the parent function is y equals x squared. If you are going to shift that thing left 1 and up 4, what would the new equation look like? Go ahead, try it. Write that new equation. Can you? I don't know. I hope so. Everybody write it. Give it your best shot. Once you have written your equation, whatever it is, I recommend then you don't look at these words and kind of go backwards and say, okay, if I was presented with this equation, what do these numbers I have in here tell me to do to the graph? Hopefully, it would be left 1 and up 4. Okay, you have it? Anybody want to give it a shot? Izzy, go ahead.
Equals in parentheses x plus 1 squared plus 4.
I agree, because I would cover this up and then I would look at this and I would say to myself, okay, this plus 4 on the end, that means up 4. A plus 1 in there with the x is really the opposite of what you think it is. So it really means left 4, well, 1, sorry. And that's exactly what we're supposed to do. Okay, let me give you one more. Let's try this. Same directions. I'm just not going to rewrite all the words. So let's say that the parent function this time is, how about y equals square root of x? And let's do, how about you reflect over the x-axis and go right 5. Try that. What would that equation look like if that's what you did? All right, who's got this? Sebastian, go ahead.
Negative the square root of x minus 5.
Is the minus 5 under the root or no?
Yes.
So like that. I agree. That negative out in front is what flips it over the x-axis, that flips it all upside down. If I want to go right 5, it's going to be a minus 5 under there with the x. Done. That's the whole test. Are you going to ace it tomorrow? Why not? I don't know. I'm hoping you will do better than you think you will. But let's practice some more. I have a review activity for us. All right.